Hello everyone. In this video I'm going to show you how to use our CIF Site Analyzer utility. So the utility is available at this link, and look at the description of this video to get this link. So this is a utility that is helpful in analyzing a bunch of CIF files belonging to a certain structure type. So in this video we will look at this example. So this is a quaternary Germanite HO4 Ni2 INGE 4 type, so in this video first I'll show you how to install this utility, and then we'll run this utility in an automated mode, and from there we can look at the outputs and understand what each output means, and then finally we'll circle back to running the code again, where I'll show you what other customization options are available. Okay, so let's get started. Okay, so to install this code, so you can download or clone the repository, and to download you can go here and then click the download zip button, or if you want to clone you can just make sure it's on HTTPS, and then copy the URL by clicking this button, and then go to your terminal and type git clone and then the link, assuming you have git installed. So I have this already downloaded in this directory in desktop, so I'm going to skip this and then go to the next step, which is setting up an Anaconda environment so that we can install all the required dependencies in a secure, in a separate Python environment that does not affect the rest of the system. So to do that, make sure you have Anaconda installed. If not, please check out our YouTube channel or other videos on YouTube or internet documentation on installation, and then copy this command to create a new Python environment with version 3.13 named CIF Site Analyzer _ environment. So I'm going to paste this and then type enter and wait for the installation to complete. Yes. Okay, so now that environment is set up, we can go ahead and activate by using this command, copying and pasting this command. We can activate the environment, and then we have to install the package. So to install the package, we have to go into the directory and then type pip install dot. So I'm already on desktop, so I'm going to cd into the CIF Site Analyzer and then paste this command and enter. So this will install the package and the necessary dependencies. Wait for a few seconds for the installation to complete. Now that's done, the package is ready. Okay, now that we have the package installed, next we are going to run the analysis of CIF files belonging to this structure type in the automatic mode. So to do that, let's get out of the clone directory, and I'm going to clear the screen, and then if I look at the contents of my current directory, I have this folder with a bunch of CIF files belonging to this structure type. So while at this point, to run the code, all you have to do is type Site Analyzer followed by the path where you have the CIF files. So once you type that, and then to run the code in the automatic mode, use the -Y flag. So with that flag, if we hit enter, the code will run and generate the outputs. Give it a few seconds. Okay, great. Now the code has completed the analysis. We can take a look at the output. So open the folder, and in the folder you'll see that a new folder with the name of outputs will be created, and that's where all the outputs are saved. So before we get into that, let's take a look at one of the CIF files so we can get to know the sites in the structure type before we talk about the outputs. So I'm going to open one of the CIF files, and if we look at this structure type, we have 1, 2, 3, 4, 5, 6 sites, of which one has the multiplicity of 2 and Wyckoff symbol of A, and the other all other 5 has Wyckoff symbol I and multiplicity of 4. So these 5 actually has the same site multiplicity as well as Wyckoff symbol. So for cases like this, the code will automatically assign an extra numeric identifier such as 1, 2, 3 and so forth, so that it can distinguish between these sites. So and the numeric identifier is consistently assigned based on the coordinates across all sites. So the occupancies or the distribution of elements that are occupying the particular site will be preserved. So if we go inside this outputs folder, we'll have 3 folders: CSV, heat maps and plots. So I'm going to go into heat maps, and then in the heat maps we have a bunch of figures, and then there's one more folder called individual. So I'm going to go into this first. So now that we are inside this folder, we can see that there are a bunch of periodic table heat maps, and this one is the element distribution of 4i, and it has the code has assigned a numeric identifier for this particular 4i site with the identifier 4, and then we have 4i5 and 4i3 and then 2a and 4i1 and 4i2. So if we look at these, we can see that 4i1 and 4i2 are entirely made of germanium, whereas 4i4 and 4i5 are rare earths, and 4i3 is 8b, and then 2a is silver, cadmium and indium. So we can see that there are one group made of rare earths, and then there's one more group made of germanium, and then a third group with 8b mostly, and then a fourth group with these elements. So we have 4 groups, and it is actually convenient to group these and analyze in terms of groups rather than the individual sites, and that's what is given in this plot. So we have G1, G2, G3, G4, 4 groups, and if I open for example group this is group 1, you can look at the beginning of the file name to see what the group identifier. So this is group 1, this is entirely made of rare earth, and then group 2 is 8b, and group 3 is these 3, and finally group 4 is just germanium. So this is the grouped periodic table heat maps. Now with in addition to these, we have 2 more. One is all of these groups stacked in a column, and then the other is all of these groups stacked in row. So that's heat maps. Now let's move inside the plots folder. So we have a bunch of SVG files, and that's why they look a little bit weird. It might look different in your system. First, let's open this file, which is PLSDA scatter plot, and in the previous folder, which is the heat maps, we saw that it actually assigns 4 group G1 to G4 for this structure type. And if we take the elements or the compositions in case there's a mixed occupancy on a particular site, what we can do is we can calculate the features corresponding to each of these sites. For example, if this site, which is G3, was occupied by silver, cadmium and indium in most cases. So for example, for indium, what we can do is we can take its physical, electronic, radii and so many properties, And likewise for each elements or combinations in each site across all the CIF files, we can calculate their features using weighted sums in case there's multiple elements or partial occupancies in a particular site. So with this we can create a feature map, and then we can do a partial least square discriminant analysis to classify each of these groups separately. So that is what exactly done in the code. So the code runs a PLSDA analysis to classify each of these groups as separate. So we have one group with rare earth and another group with mostly 8B, and then this is the germanium silicon group, and then this one as the silver cadmium indium group. So with this, once this is done, what we can do is we can take the elements that are not on this data set and calculate their features, right? Since the features are mostly elemental properties, so they are already known, there's no need to calculate them again. So since we have the features readily available for the elements that are not in the data set, we can calculate the features and then feed it through the same PLSDA model to get their coordinates. So what we are doing two component PLSDA, so we can easily visualize the outputs in a scatter plot like this. So for the new elements also, we'll get the same 2D coordinates for each element, and we can actually plot them along this side. So if you think about it, we in the traditional periodic table, you have groups and periods as the coordinates, and in this case we are just transforming that in a different coordinate system. They are not periods and groups anymore. So once we project other elements, what we will get is this plot. So this is more or less the same plot as the previous one, and if I put side by side, you can see that the elements are occupied relatively at the same position, except that here we have the labels visualized, and in addition to that we have the elements that are not present in the dataset plotted. So they are plotted with this white circle, whereas everything else will be assigned a different color. So if it looks like white, then it is not part of the dataset. But what this tells us is that which elements are close to the groups that are identified, and this can be exploited toward new compounds. So next, let's look at the other outputs. So now that we have these coordinates for elements, what we can do is we can actually plot the compounds using these coordinates by taking the weighted average. So for example, in the case of the title compound of the structure type, which is HO4Ni2 INGE4, so we can take holmium's coordinates, which are here. Well, excuse me, let me open a different plot for that. So if we open this one, element visualization.svg, we can see a much better picture of the same diagram that we saw. So here we have holmium right here. So it has an x and y coordinate, x and y. So we take that and multiply by 4, and then we take the nickel's coordinate and multiply it by 2, and then we take the coordinates of indium, which is right here, and then multiply it by 1, and then take the coordinates of germanium and multiply it by 4. And then if we add it, we'll get an average. If we do a weighted sum, we'll get an average coordinate which will lie somewhere around here. And we can do that for all the compounds in the data sets, and if we do that, we will get this plot where all the compounds are plotted according to their weighted sum of coordinates of the elements. So and the gray line shows the connectivity. So you can see all of the compounds belonging to this structure type are clustered here. So what this gives us is an opportunity to compare new compound by using this coordinate. For example, if you want to take a new compound that for example, you're substituting say ytterbium in the lanthanide side, the 4i 4 and 4i5 side, so or the G1 side, the group. For this, what you can do is you can calculate the coordinate of the compound with ytterbium substitution and then plot it and see whether it lies close to the existing distribution of compounds or not. So that's the utility of this plot. Okay, so now that we have seen the major plots, there's one more plot that we have to see here is this feature loading. So in creating the PLSDA, so we are doing a 2-component PLSDA, and the 2 components are weighted sum of individual atomic features, or linear combinations of individual not atomic elemental features. So it'll be electronegativity times 0.1, radii times 0.4, and Mendeleev number times negative 0.1, and so forth. So and it is actually useful to know how the loading span across these 2 latent variables. So that is what is shown in this feature loadings plots, and we have color coded them based on their similarities. So for example, all the radii are clustered into this blue group, and then valence properties are grouped into orange group, and thermal and physical properties are in green, and so forth. So this plot gives you a glance of which type of features influence the coordinates positively, and which type of features influence the coordinates negatively. So that's the utility of this plot. Next, let's look at the CSV folder. So if I go inside, there are 4 files. So let's start with this one. This is the structure type.csv file, which has the formula, file name, prototype, and number of elements, and the composition for each site, as well as the composition of the group sites. So that is what's listed in this CSV file. Next, if we look at this file, which is the coordinates.csv, these are the PLSDA calculated coordinates for all the elements that are in the dataset, as well as the elements that are not in the dataset, which we saw in the scatter plot earlier. Okay, and then this file contains the loadings for each component for each of the features. So component 1 has a loading of 0.1 for atomic weight, whereas component 2 has a negative 0.13 for atomic weight, and so forth. So you have the loadings of all the features that are used, and it's actually good to know which are the top 10 contributing features for each component, and that's what is provided in this file. So the top contribution for each features and the explained variance by each component is listed in this title, and the top 10 contributing features are listed under each component name. So these are the features contributing to component 1, and these are the features contributing to component 2. Okay, now it's time for us to run this code again, now with the interactive mode or without the automated mode. Okay, so to do that, first I'm going to remove the existing analysis output. So I'm going to type rm outputs, and since it's a folder, okay, so now we don't have the outputs folder inside this directory. Okay, so Now let's run this again. Site Analyzer followed by the folder where we have the CIF files, and now without any flags. Okay, so now it asks, okay, these are the sites present in this structure type, and the automatic group that's assigned this. So G1 has the group naming is arbitrary, so you don't always get the consistent group name. So that is typical. Okay, so now it says there are 4 groups. The first one has 2A, the second one has 4I1 and I2, which were grouped into one group in the previous analysis too, but it had a different group identifier, which is not significant. It always changes. And then there's one more group with 4I3, and then the last group has 4I4 and 4I5. And now if you want to accept, you can type Y, and if you want to customize, you can type no. I'm going to type no so that I can show you how to do the customization. So to customize, you can assign the group labels yourself. So what I'm going to do is I'm going to just assign the reverse of the name. So for example, I'm going to assign a group name G4 and a group label G4, and I'm going to say there's only one site under this, so which is 2A, and then I'm going to type G3, and then so in this case I have 4I1 and 4I2. So we can just copy 4I1, 4I2 and then paste it. So they had to be separated by comma. And then G3, G2, label G2 is 4I3. And finally G1 is made of these two. Okay, so now that we have reassigned, oh my bad, so make sure it doesn't include this inverted commas, so it's a good idea to copy from this line, so that if you are copy pasting, of course. Now we have assigned the groups manually. In this case, all we did is just change the labels, but you can actually customize based on your judgment for this particular structure type under study. Now that's over, the next option we have is to choose colors. So it automatically assigns blue for G1 and gray for G2 and so forth. So so if we look up our group labels, so G1 is 4I4 and 4I5. I think that's actually rarest if I remember correctly, and I think that's the correct color. Not sure, but so I'm just going to accept for now the colors, but if you want to customize, you can type N and then use the same workflow to assign colors. Okay, so I'm going to accept these colors, and then it'll automatically generate the group heat maps as well as individual heat maps. And then it'll do the PLSDA, and now it actually presents us an opportunity to add new compounds. So do you want to add new compounds for comparison? So I'm going to say yes, and for the new compound we have to enter the site composition separated by comma. For example, we can take a look at this output to get an idea of which elements might go to which side. So I'm going to type the title compounds HO4, Ni2, and then G3 is In, and G4 is Ge4. Okay, so do I wish to add more compounds? No, at this time I would like to only compare this compound. Okay, with that the analysis is done. Now if we go inside the folder, the important difference is that it's in this plots where we have the compounds. Now if I open this, there's an additional point that is marked in red. So the compounds that are marked in red correspond to the compounds that you have entered under the new compound category. So they will be marked red. So that is what the advantage of using that option. So if you want to compare a new, if you want to see where a potential new candidate lies with respect to the existing compounds in the data set, you can do so using that option. So that's all in interactive mode, and I hope this tool is useful for you, and I hope this video clarifies most of what the code does. And if you have any questions, feel free to let us know in the comments or in the GitHub issues. Thank you.